guys! Welcome to General Physics 1, and this is Gisela Mombales of STEM 12 Lindale. For today's video, we were going to tackle the addition of vectors including the graphical and vector component method. Let's start solving problem using graphical method. But wait, what is graphical method? The graphical method of adding vectors A and B involves drawing vector on a graph and adding them using a head-tail method. Before we start our discussion, we will define vector and resultant vector which we will encounter during our discussion. According to Google, vector is a quantity having direction as well as magnitude, while the resultant vector is the combination of two or more vectors. To understand more the difference between vector and resultant vector, here are examples. 2 meter north to west. The direction is west towards north. The north to west is what you call vector. The resultant vector could only possible if we put an arrow between the end point of west and starting point of the north. After discussing some terms, we will now proceed to problem solving. A delivery boy needs to travel 10 km east, 8 km 35 degree east of north, 16 km west, and 12 km 55 degree west of south. So first, let us write all the given vectors, and in this method, all we need is ruler and protractor. We have to place all the given vectors in a Cartesian plane. Remember that each grid represents 2 km. 10 km east, 8 km 35 degree east of north, 16 km west, 12 km 55 degree west of south. To find the resultant vector on this problem, we measure starting point up to the end point using the ruler. The resultant vector of this problem is 11 km, which is measured by our ruler, and the angle is 2 degree, which is measured by our protractor. And to find the direction, since it went to west up to the south, the direction of this problem is south of west. And now we are done in addition of vector using graphical method. We will now proceed to another method, which is vector component method. Aside from graphical method, the component method is another way to add vectors. It involves katawa. We will be using the same problem to know if the answer will be the same. We will now proceed to problem solving. A delivery boy needs to travel 10 km east, 8 km 35 degree east of north, 16 km west, and 12 km 55 degree west of south. So our first step is to write all the vectors that are given. 10 km east, 8 km 35 degree east of north, 16 km west, and 12 km 55 degree west of south. In solving the component method, we will use the table of components. This table consists of vectors and x and y component. Remember that east and west are for x component, and east and north are positive values, while north and south are for y component, and west and south are negative values. In the table, we will place first the 10 km east and 16 km west, since these two are single directions. First, 10 km east. We put 10 km to x component and 0 km to y component. Next is 16 km west. Since south and west are negative value, it is considered that x component is negative 16 km and 0 km in the y component. And for the second and fourth vectors, we will use the trigonometric sine and cosine function to find its y and x component. First step is to know the direction of the second vector. It is east of north. It comes from north towards east. Therefore, the angle theta will be placed between the resultant vector and the north direction. Next step is to determine which is the opposite side and adjacent side. But most of the student is confused on it, so that they got wrong answer. We will analyze which is the opposite side and the adjacent side. The opposite is in the east direction and the adjacent is in the north side. Take note that our angle theta is 35 degrees. We will use a trigonometric cosine, which is cosine is equal to adjacent over hypotenuse. We will substitute the given value, so 8 cosine 35 for the x component, and the answer is 4.59. And we will use the 8 sine 35 for the y component, and the answer is 6.35. Take note that they are both positive because the east and north are in a positive value. Now we are done inputting the x and y of the second vector. We will now proceed to the last vector. 12 km, 55 degree west of south. So, the first thing to do is to know the direction. Directions come from south toward west. Since 12 km is the hypotenuse, we will use for the x component is the trigonometric sine function. And the angle theta is between the resultant vector and the south side. And next, we will determine the opposite and adjacent side. The west is the opposite side and the south is the adjacent side. We will now substitute all the given values. So, 12 sine 55 for the x component, that gives an answer of 9.83, and for the y component, we will use the 12 cosine 55. That will give an answer of 6.88. Since it is in west and south side, the final answer for the x component is both negative. Negative 9.83 and negative 0.88 for the x and y component. Now that we already put the x component and the y component of all the given vectors, we will add all the given, and the summation for the x component is negative 11.24. And the summation for the y component is 0.33. Negative 0.33 rather. Explains that when the x component is in negative value, it goes to west. And when the y is also a negative value, it goes to south. So, our direction is west of south. Next step we do is to find the final resultant vector. The direction we will use is west of south. It means that from south towards west. Our angle theta is in between the resultant vector and the south side. To solve for our final resultant vector, we will now use the Pythagorean theorem. Resultant vector that represents r is equal to the square root of 11.24 squared plus 0.33 squared. Just type it on a calculator, your calculator, and our final answer is 11.2 km. For the last part, we will now proceed to the tangent theta. Tangent theta is equal to opposite over adjacent. We will now substitute the given value so that tangent theta is equal to 11.24 over 0.33. And again, just type it on the calculator. That gives us an answer of 88.3 degree west of south. For the last procedure, we will now subtract 88.3 degree to 90 degree to find the south of west direction. And the final answer is 1.7 degree south of west. Therefore, our final resultant for this problem is 11.2 kilometer, 1.7 degree, and the direction is south of west.